In this video, we are going to derive the unit circle using special right triangles. First, let's revisit our special right triangle relationships. So we learned about 30, 60, 90 triangles, as well as our 45, 45, 90 triangles. And this picture shows the relationship between the different side lengths of those special triangles. So we're going to use that idea to help us derive the unit circle. A unit circle is a circle whose radius is 1 unit of distance. We're going to use these relationships to explore the unit circle as we complete this task. We're going to use the 30, 60, 90 triangle graphed in this unit circle on the coordinate plane to complete our discovery. So first, we're going to find and label the side lengths of each side of triangle ABC. So knowing that this triangle is inside a unit circle, and for a unit circle, the radius is 1 unit in length. So I'm going to label my radius 1. In order to find the other lengths, I'm going to use my special right triangle relationships. So because this is a 30, 60, 90, and I know the hypotenuse, that means I know that the hypotenuse is 2 times the short leg. So the side length that's right opposite our 30-degree angle. So since this is 1, my short leg is going to be 1/2. And so then my long leg is going to be my short leg times square root 3. So it's going to be 1/2 times square root 3, which I can write that as square root 3 over 2. Now, what I want to do now is I'm going to determine the coordinates of point B and then label this point on the unit circle. So I notice the coordinates for point B is here. And when I think about the coordinate plane, I know this is my x-axis and this is my y-axis. I know the coordinates are defined by the distance along the x-axis as well as the distance along the y-axis. So when I look at the coordinate B, I notice if I start at the origin, it's about square root 3 over 2 units away from the origin on the x-axis. So I'm going to name that x coordinate square root 3 over 2. And then I notice my y coordinate, the distance is 1/2 for my vertical distance. So I'm going to label that 1/2. So the coordinates for B will be square root 3 over 2 and 1/2. Now I want to find the values listed below. So using what I learned about right triangle trig. So if I look at this triangle, I want to figure out the sine of 30 degrees. I know sine is represented by opposite over hypotenuse. So in this case, it's going to be 1/2. Cosine is represented by the ratio between the adjacent side and the hypotenuse. So square root 3 over 2. And then tangent is going to be my opposite side divided by my adjacent side. So in this case, it would be 1/2 divided by square root 3 over 2. And so when I do my mathematics here, I know that for this, I have to multiply by the reciprocal, which would give me 1 over square root 3. And then to handle that radical, I'm going to multiply both sides by square root 3 over 3. And so that gives me square root 3 over 3. So that would be my tangent for 30 degrees. So now, to help me derive the rest of the unit circle, I'm going to do some reflections. I'm going to think about what I know about transformations, rigid motion, and I'm going to use some reflections of this initial 30, 60, 90 triangle. So I'm going to use my triangle cutout. I'm going to place it right on top. And so the first direction says to, now we're going to reflect triangle ABC across the y-axis, and we're going to sketch triangle A prime, B prime, C prime. So I'm going to take this triangle, and I'm going to reflect it across the y-axis like this. Now notice when I reflect, I don't see my angle measurements anymore. But if I remember what I know about transformations, I know that the angle size is preserved. So this is going to be my 30-degree angle. This is going to be my right angle. And then at the top here will be my 60-degree angle. So I know that the angle measurements are going to be the same, as well as the side lengths are going to also be the same. So I'm going to reflect. And now I want to label, I'm going to trace this triangle. And I'm going to now label coordinate B prime, and figure out the coordinates for B prime. Okay, so again, thinking about what I know about transformations. So I know that these side lengths are going to be exactly the same. So my radius is still going to be 1. This side length is going to be 1/2. And then this side length is going to be square root 3 over 2. But when I think about my coordinates, I want to think about where I am in terms of the coordinate plane and which quadrant I'm in. So I notice now when I think about my coordinates and my distances, so if I think about the distance along the x-axis, so yes, it's still square root 3 over 2, but I know now that I'm moving to the left of my origin. So this is going to be negative square root 3 over 2. And then my y distance, so my vertical distance, is still going to be positive 1/2. Okay. So I noticed the coordinates are the same, but I noticed that on this side, my x coordinate was negative, but my y coordinates are still positive for both of my sides. Okay, so now I'm going to continue my reflections. And so this time I'm going to reflect my new triangle across the x-axis. And I'm going to think about the coordinates of my new point, which would be B double prime. So if I flip this across the x-axis, it would look like this. And I'm going to trace my triangle on the unit circle. Sketch. Okay, so again, because this is a reflection, I know that my angle measures are going to be the same, as well as my side lengths are going to be the same. And so again, that radius is going to be 1. This side length is going to be 1/2, because that would be the reflection point. And then this same side length is still going to be negative square root 3 over 2. So if I label this point now, this is going to be B double prime. And now I want to figure out the coordinates for this new point. So again, if I think about my x distance, my horizontal distance, and I'm going to also think about my vertical distance. So my horizontal distance is still going to be negative square root 3 over 2. And my vertical distance is 1/2. But again, I want to think about which quadrant I'm in. So I know now I'm in this third quadrant, and in the third quadrant, my y values are negative. So if I think about this part of my y-axis, I know that the numbers as I move down, they're negative. So this is going to be negative 1/2 for my coordinates. Wondering what patterns I noticed. I noticed so far that all of the x coordinates are square root 3 over 2, except some of them are positive and some of them are negative. I also noticed that the y coordinates are the same so far. The 2 at the top were positive and this one is negative. So I can almost make a prediction about what's going to happen in this fourth quadrant. So I think my prediction is going to be, I think that the coordinates are going to be the same, but the signs are going to be different. So let's see what happens. So if I take my triangle and now I'm going to reflect it one final time across the y-axis. Take it and reflect it. And I'm going to trace where it lands, kind of sketch. Okay, so again, I notice my angle measurements that are congruent. And now let me think about my side length. So as I reflect it across the x-axis, this still has a distance of 1/2. This radius is still 1. And then the distance across my x-axis is still square root 3 over 2. So when I think about the coordinates B triple prime here, x coordinate, square root 3 over 2. And then my y coordinate, my vertical distance is 1/2. And so again, thinking about which quadrant we're in. So if I'm thinking about a coordinate in this point, the fourth quadrant, my x coordinate is going to be positive, but my y coordinate is going to be negative. So this is going to be negative 1/2. So now I have used my 30, 60, 90 degree triangle to derive the first part of the unit circle. Now we're going to explore what happens when we have a 45, 45, 90 degree triangle inside of a unit circle. So remember, the radius for our unit circle is 1 unit in length. So let's consider this 45, 45, 90 degree triangle shown, and we're going to determine the coordinates of point B. And so I know it's a 45, 45, so these angle measures are going to be 45 degrees. So thinking about my special right triangles in a relationship, I know that with 45, 45, 90 triangles, the two legs are going to be the same length, and the hypotenuse is going to be whatever that leg length is times square root 2. So the first step is to label each side of our triangle. So I know my hypotenuse is 1, and so if I want to figure out my leg lengths, I have to think about the hypotenuse is equal to x times square root 2. So thinking about the relationship with my 45, 45, 90s. And then if I solve for x, I will know my side length. So I'm going to divide both sides by square root 2. And so I get x is equal to 1 divided by square root 2. And so we can rationalize that denominator by multiplying both sides by square root 2 over 2, which would give us square root 2 over 2. Okay, so my two leg lengths are going to be square root 2 over 2, square root 2 over 2. And so when I think about the coordinates for point B, again, it's going to be my horizontal distance. So thinking about how far we are away from the origin on the x-axis, and then thinking about my vertical distance. So how far vertically we are away from the origin. So for my x coordinate, I notice that I am square root 2 over 2 units away from the origin. And then to get to B, I have to go up square root 2 over 2 units up my vertical. So the coordinates for point B are going to be square root 2 over 2 and square root 2 over 2. So now we're going to take our 45, 45, 90 triangle, and we're going to reflect it into each of the quadrants, just like we did on the first page. And then we're going to see what we get. All right. After performing my reflections, I was able to figure out the coordinates for B prime, B double prime, and B triple prime. I noticed that the numbers were all the same, again, just like the 30, 60, 90, but the the signs were different depending on which quadrant the point lied in. So now I can use my triangles to figure out my sine, cosine, and tangent values, and I can use any of my triangles. So thinking about what we know with right triangle trig, sine of 45 degrees is opposite over hypotenuse. The cosine of 45 degrees is represented by the adjacent over hypotenuse relationship. And then I know tangent is opposite over adjacent. So it has square root 2 over 2 divided by square root 2 over 2, which is just going to be 1. So now I can use the same understanding with the 30, 60, 90 triangle again, but this time using 60 for my reference angle and see which coordinates I get. And then we will take all of our coordinate values from all 3 circles and compile it into one large unit circle.